Let us create some functions using Python. One of the main benefits of programming in Python is the ease of building functions. It's like basically building with Lego bricks. Suppose you want to define a function that takes a number and multiply that number by itself and produce the square of that number. We're going to use def keyword, the name of the function, and we pass in some arguments, the colon, don't forget the indentation, and what does it do? It takes the number and multiplies it by itself, and it returns the output value. The def is short for define, and lets Python know that we are about to define a new function. In this case, we called the function square and gave it one input variable or one parameter or one argument. Please note that a function can take on more than one argument. So the syntax is you have def keyword, you have the name of the function, and you pass in a parameter or argument. Then you have the body of the statement, and it returns that expression. In Python, a function definition starts with the keyword def, followed by function name, parentheses, and a colon. Inside parentheses, we can specify any parameters or argument. What is a snake casing? Snake casing is a naming convention in programming where words are all lowercase and separated by underscores. It's commonly used in Python for naming variables and functions. So take a look. We define a function, say underscore hello. What does it do? It basically prints hello for us. So if we call the function, say underscore hello, the output value is hello. Let's make it more interesting for you. Let's write a function that greets people. We define greeting function and passing the argument name, and then it prints f string. So our function definition using def keyword. We name the function greeting, and the function has just one parameter or argument, which is name. So it takes name and it prints the name. Take a look. When we're talking about f string, it basically, inside the function, there is a print statement, and that uses f string to include the value of the name parameter in the printed message. And f string allows you to embed expressions inside string literals by placing them inside curly braces. So in this case, the name gets replaced with the actual value passes to the function. So here you have print, open close parentheses, f, single quote, hello, space, open curly bracket, the name, which is the exact same argument here, and it close the bracket, single quote, and that's how you build your f string. For example, if you call the function greeting and passing name John, we get hello John back. Let's do a little bit of calculations, adding function. Let us define a function that adds numbers. We're going to call this function add underscore number, pass in two arguments, num1, comma num2, colon, indentation, and then return the addition of these two numbers. Again, remember the syntax. We use the def keyword to define the function, and it has two arguments. The return statement, it returns the addition of these two numbers. It sends the result of number 1 plus number 2 back to the caller. This means that when the function is called, it will compute the sum of number 1 and number 2. For example, if we call the function and pass in two arguments, 4 and 5, we expect to get 9 back. A common question is, what's the difference between return and print? The return keyword allows you to actually save the result of the output of a function as a variable. The print function simply displays the output to you, but it doesn't save it for future use. For example, if you define a function, print underscore result, and pass in two arguments, a and b, and ask it to print the summation, and also define another function, return underscore result, pass in two arguments, a and b, and ask it to return the addition. If you call print underscore result function and pass in 10 and 5, we get 15 back. But you won't see any output if you run return underscore result 10 and 5. Very good. So how do we add more complexity to our function? We can use conditional statements. If, elif, else statements to add more complexity to our functions. If statements in Python allows us to tell the computer to perform alternative actions based on a certain set of results. Verbally, we can imagine we are telling the computer, hey, if this case happens, perform some action. We can then expand the idea further with elif and else statements, which allows us to tell computer, hey, if this case happens, perform some action, else. If another case happens, perform some other action, else. If none of the above cases happen, perform this action. So this is the general syntax we use for conditional statements. If case 1, colon, indentation, perform action 1, elif, case 2, colon, you have indentation, perform action 2, and then else and colon, perform action 3. If you have some condition, do the following. Very good. Let us define a function, define function sign, and pass in argument x. If x is positive, it returns positive to us. So this is a very simple function that uses conditional statement. If you call sign function and pass in 3, since 3 is positive, we expect to get positive back. But the question is, what if we pass in negative? What if we pass in 0? So we need to add more complexity to this function. Let us define function sign, pass in one argument. If that argument is positive, it returns positive. Elif, if it's negative, it returns negative. So now if I pass in -3 and call this function, I get negative back. And again, what if we have 0 here? We define our function, pass in the argument. If x is positive, it returns positive. If x is negative, it returns negative. Else, it returns neither positive nor negative. So if I call the function and pass in 0, I expect to get neither positive nor negative. So as you know, 0 is not positive and it's not negative. We're going to add more complexity to our function using for loops. For example, here, for I in range 5, print I. We can add more complexity to for loops by using inner loop and outer loop. Later on, we're going to discuss this in our class. So let us begin for loops. A for loop acts as an iterator in Python. It goes through items that are in sequence or any other iterable item. Objects that we learn about that can iterate over like strings, lists, tuples, and even building iterables like dictionaries such as keys and values. We've worked with for before, but now we're going to delve in more into details. So here's the general format for a for loop in Python. For item in object, colon, indentation statement to do stuff. So suppose you have a list This list includes numbers 1 to 10 inclusive. For number in list 1, print those numbers. So if you just run this cell, we expect to get the numbers that are listed in the list. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All of them are printed here. Let us define a function, check if you have even numbers, and use for loops. As you remember, we use def keyword to define the function. The function has name check underscore underscore list, and we pass in the argument number underscore list. The function is called check underscore even underscore list and accepts one argument, and it looped through the list. For number in number underscore list, the for loop iterates through each number in the list. Once we get a hit on an even number, it returns true. So take a look. I'm using the mod operator for the remainder. If you divide that number by 2 and the remainder is 0, it's comparable to 0, then it returns true. So basically check if the number is even. As you know, if you have an even number, dividing by 2 result in remainder 0. Another instruction, don't do anything if it's not even. So else, pass. And finally, return false. So please notice the indentation here. It returned true for even numbers. If the function finds an even number, it immediately returns true. This stops the function because we know at least one number is even there. It doesn't do anything if you have an odd number, so it passes. If the number is odd, the else block is executed, but pass just tells the function to skip the next iteration without doing anything. Return false if no even number is found, so it is just return false. This line is outside the loop, meaning it only runs if the entire list has been checked and no even number were found. So in this case, the function returns false for you. So the whole block is here. Now we're going to check the following list. The list includes 1, 2, 3. So we see at least one even numbers, which is 2. So we expect to get true back. So basically our function takes this argument number underscore list. For number in the number underscore list, if the division between the number and 2 has remainder 0, it returns true. Otherwise, it passes. And finally, after checking everything in the list, if there is no even number, it returns false. So here you have at least one even number, so we expect to get true. But if I pass in the list including 1, 3, and 5 and call this function, we expect to get false back because there is no even number here. Perfect. In the next step, we're going to talk about simulations.